In 6.1, you're going to solve inequalities by addition and subtraction. So what makes an inequality different from an equality? In the past, you had like 2x would be equal to 10, and then you would divide both sides by 2. So instead of having that equal sign there, you're now going to have greater than symbols, less than symbols, or somewhere it's like less than or equal to. And since all of these only involve addition or subtraction, that's all we'll deal with today. X minus 45, we're told to solve by adding, is less than or equal to 13. Now, get that written, but in your head, picture an equal sign here. Because if this was a problem where you just had an equal sign, then you would have real quickly added 45 to both sides, solved the problem, and then been done with it. But it's not an equation, it's an inequality. So doing this problem is no different, but you just have different symbols. So you kind of just want to imagine it's not even there. Don't let it be complicated. Keep it simple. So we solve this by adding. Now whenever you do these types of equations, you always want to check them, and you usually want to graph them. Now I'm not going to plot all the way up to 58, but what I can do is I can just make like a mark for 60, or if I wanted to, I can make a mark for 50, and then show 58 over here. But let's take a look at something. We have less than or equal. And because it can be equal, we need to talk about the difference of how you would show this. Well, when we plot on a number line and we want to represent the value of something, we normally would draw a dot. So over here on the side, show a dot, but make sure it looks like it's filled in. And if you have a filled in dot, that means it's going to be included. And what that means is that the answer, 58, is a possibility in this equation. So when I go in and I make my dot on the graph, I would make a solid circle. Now this doesn't have to be crazy big. It looks silly if it is. You should be able to make that clear. Now the opposite would be if it was just simply less than, then we would have a circle, like kind of a dot without being filled in, and it would not be included. So my handwriting's a little shoddy there, but I have NOT space INC for included. And since I see included here, I think that's pretty clear. Now, X can be less than that. So X would be less than, and to shade this in, we are going to make a slightly larger than our number line arrow to the left. Now, I should have said it earlier, but if you're not doing these with a ruler, you need to. And keep in mind I'm using an iPad. Your handwriting should be neater than mine. Now let's talk about how we check these problems. You can check these at any point along the way. So we found out that X pivots or changes at 58 here. So I'm going to check 58 as a first way of checking. So here's X. I have 58, and if I subtract 58 and 45, I would get 13. So at that point where it changes, I feel good about what I have graphed. Now the other thing too, inequalities do not just have one solution, they don't just have two solutions. They might have no solutions or infinite solutions, and this one actually does have infinite solutions. Yeah, and that's kind of different, that's kind of strange, because even though like 100 is not an option, there's an infinite number of numbers to the left of 58. And let's try a nice one that would cancel out. Let's think about 0. Usually 0 is nice, because if we multiply by 0, we get nothing. So in my head, I'm thinking 0 minus 45 would be negative 45, and that's definitely less than 13. So not only am I checking this pivot point, I'm also checking something on the area and the direction I shaded. Because if I found out that I was wrong, that would mean I'd have to switch the direction of my shade on the inequality. Now, I've talked about checking the actual intersection point. I've also talked about checking 0. Another option is to check an extreme. And so when I say extreme, I mean something outrageous. In math, by trying extremes, you can usually really help yourself understand a situation because it makes it that much more ridiculous. So let's imagine negative 1 million, because that would be way far to the left on the number line. If I put negative 1 million into X, then subtracting 45 really has almost no effect at all. and negative 1 million is definitely less than 13. If we look back at this problem, we can box our solution, and you're probably saying to yourself, well, hold on. We solved that so quickly, but then this video kept talking and talking and talking. Well, the purpose of these talks is so that you can really find your solutions accurately and make sure you're checking them many different ways and looking at these different ways. Okay, let's take a look at the next inequality we have. Set up the second problem where you have 22 is greater than m minus 8. A little bit of a tip. If you wanted, you could rewrite this in a different direction. A lot of people like to see m minus 8 on the other side, and then 22. But if you do that, you'll have to change the direction of your inequality symbol. I won't do it that way, so follow along with me the way I'm doing this one. Let's look at this and remember, pretend this isn't even here. It makes it complicated. It's just an equal sign in your head. So let's add 8 to both sides, because that's how you would have solved these one-step equations in the past. And then we'll get 30 on the left side is greater than m. Now whenever we do these problems, it's strange to say 30 is m or 30 is greater than m. Usually it's a lot more clear if we talk about the variable first. But now I'm changing the direction, so I'm not going to say m is greater than, I'm going to say m is less than 30. For me, it's so much easier to picture a value that is less than 30. If I say, well, m is less than 30, maybe I immediately think of 0. As opposed to if I say 30 is greater than m, that slows me down a little bit and it makes it difficult for me to think about values where 30 is greater than m. For me, that's just the way, the direction in which my brain thinks. Let's check this since we have an answer, because it would be kind of a bummer to draw the number line and everything only to find out it's wrong. Plugging in 30, I get 30 minus 8 is 22. So that gives me that pivotal point where my values will become false versus true. Another thing I can test is 0, because 0 is less than 8. I'm sorry, 0 is less than 30. 0 minus 8 gives me a negative number, which is definitely less than 22. I can also think about a number like negative 1 million going in here. Negative 1 million minus 8 is extremely negative. That's extremely to the left of 0, and it's way less than 22. Make sure you have a ruler out. Set up your ruler directly on one of these lines and draw a neat straight line. I like to give myself a frame of reference. Now I could either put 0 here or here, but placing it on the right is a mistake because 30 is going to be a positive value. So maybe I just do 0 and 30, and I'm going to end up shading in m is less than 30. Now let's look at this. If m is less than 30, then that means that m cannot equal. So yeah, m cannot equal 30, and because it cannot equal 30, that means that you're going to have to draw an open circle at 30, not shaded in, and since m is less than, I will shade to the left. Now, I've already talked about how we check that, but you could again kind of think, okay, well, did I get my inequality right? Well, yeah, we did because it's open. Also, did you shade in the correct direction to the left? Well, yeah, you did because that's less than. Let's make problem 3 an OYO problem, and I'll just put the solution up in a moment. So pause this video if you haven't already. Okay, if you want to look at this for a moment and see if you got the same thing I have, do that. I'm going to talk about how I would check this. Okay, if I plug negative 5 in here, negative 5 minus 14 does give me negative 19. I do see that it is it's greater than or equal, and I did shade in here, so I'm good there. The other thing, too, is I drew 0 here, which means if I picture this line, it will go through 0. So 0 is a possible answer. And 0 minus 14 is greater than negative 19, because you get negative 14. Now, sometimes comparing negatives makes it more confusing. So let's try a very large number, like 1 million, because 1 million would be way over there. So if I plug 1 million in, taking away 14 from 1 million does not make that big of a difference. So we're going to be extremely positive there, and that's definitely greater than a negative number. Now, if you have something like this drawn, that's completely incorrect because your negatives need to be over here. So what made this problem different from the last ones is that we have 0 over on the right side. If that bothers you and it helps you to see a 5 over here, go ahead. I'll make one last comment. None of these ended at problems that weren't really either crazy large, like 58 I think is what we got, or a nice multiple of 10, like when we got 30. But this one also is a multiple of 5 because it's just starting and stopping at -5. But let's say you had something that stopped at like -3. You would want to show tick marks here and not just cut a corner by showing 0, 3. You know, textbooks might show that, Wolfram Alpha might show that, but I'd prefer you be a little bit more thorough. We'll stop this video here before moving on to the other types of problems.